rational equation or rational inequality is an equation or inequality with at least one term have a variable expression in the denominator, or at least one term having a variable expression raised to a negative integer power. So these are like examples of rational expression for equation or inequality. As you can see, this one here, we have x to the power minus 4. So what that means is we have 1 over x to the power 4. Remember, if you add a to the power of minus n, that's the same as 1 over a to the power of n. So if you see a negative exponent, this is really is 7 times 1 over x to the power of 4. So as this one, that would be minus 8, 1 over x to the power of 2. So as you can see, if you have a negative exponent, that's considered to be a rational equation, or in this case, inequality. Let's take a look at this first example. Solve x plus 2 over 2x plus 1 is equal to 1. You notice that the expression is undefined for x is equal to minus 1/2. So what we see on the bottom of the fraction, 2x plus 1, if that is equal to 0, if I solve for x would be equal to minus 1/2, and that value minus 1/2 would cause this whole expression becomes undefined. That's what we have this note here. What we need to do here is to multiply both sides by 2x plus 1. Multiply both sides by 2x plus 1. Or in other words, you can look at it as being a cross multiplication. This is like a proportion. You can cross multiply. So we have 1 times 2x plus 1 is equal to x plus 2. Or look at the whole picture here, and the LCD is 2x plus 1. If I multiply them by 2x plus 1, I eliminate the fractions. So the next step is to solve for x. You get x plus 2 is equal to 2x plus 1. You move all the x to one side of the equation, all the numbers to the other side, so we get x equal to 1. So the solution set would be 1 in the brackets. Graphical solution, x plus 2 over 2x plus 1 minus 1 equal to 0. First, we need to define y1 as being x plus 2 over 2x plus 1 minus 1. Using the x-intercept method shows that the 0 of the function is 1. If you use your graphing calculator, you see that your graph going to intercept at this point on x-axis, and the solution would be equal to 1. Let's take a look at this other example. Using a rational equation, solving a rational equation. For this one, we're going to take a look at what we have at the bottom of the fraction again and see for what value of x this would be undefined. Here we have x squared minus 4. If I factor, this would be x minus 2 times x plus 2. So as you can see, x minus 2 cannot be equal to 0. X plus 2 cannot be equal to 0. So x cannot be equal to 2. X cannot be equal to negative 2. So for this equation, you can multiply each term by LCD. The LCD here is x minus 2 times x plus 2. We do this to eliminate fractions. Once you multiply them by LCD, you get a linear equation where you can distribute, combine like terms, and you get the second order equation. This equation is equivalent to what we had originally. So multiplying each term by LCD will allow us to look at the equation standard form without any fractions. Now I can factor this and solve for x. I get x equal to minus 5, x equal to 2. But remember, we said x cannot be equal to 2 at the beginning. So x equal to 2 is not a real solution. And this is also known as extraneous. When you see one of these is not a real solution, you cross it out and you would write the solution as only x is equal to minus 5. The graphing calculator solution for this problem here, we're going to let y1 equal to the left side of this equation. And then if you plug that into your calculator, you can see the graph of your equation, and also you can see the point of intersections. The solution set is minus 5. So these are the steps that we talked about. You may want to write this on your summary sheets. Solving a rational equation. Step number 1, it says to determine all values for which the rational equation has undefined expression. So we look at what we have at the bottom of the fraction, and we want to see for what value of x our expression becomes undefined. We let whatever expression at the bottom of the fraction equal to 0 and find those values. So step number 2, to clear fractions, multiply each side of the equation by the LCD, least common denominator. That would eliminate all the fractions and we get a linear equation out of that. And then we solve the equation, and then you would reject all the values that you find from the first step, which would make our equation undefined. Solving irrational inequality. Let's take a look at this example. We want to solve x plus 2 over 2x plus 1 less than or equal to 1. First step is to move everything to one side of the inequality. If I subtract 1 from both sides of the inequality, I get x plus 2 over 2x plus 1 minus 1 less than or equal to 0. I need to combine these two, so the LCD is 2x plus 1. So if I multiply this by 2x plus 1 over 2x plus 1, I would get the same LCD here. So I can combine these. So I get x plus 2 minus 2x plus 1 over 2x plus 1. If I go ahead and distribute this minus, then I can combine like terms. So as you can see at this point, we have everything in one side of the inequality. We get minus x plus 1 over 2x plus 1 less than or equal to 0. So at the top of the fraction, we have minus x plus 1. At the bottom of the fraction, we have 2x plus 1. You want to set both of those equal to 0 and find the values or the solution for these. So we get x equal to 1 and x equal to minus 1/2 if I solve these two. Now, when we get two solutions, the two solutions minus 1/2 and 1 would create three regions. If I put it on the number line, this is minus 1/2. This is 1. You create three regions, all the numbers from negative infinity to minus 1/2. And then one region would be all the numbers from minus 1/2 to 1. And the next one would be all the numbers from 1 all the way to positive infinity. What we need to do is to pick a test point, one point, within those regions if it makes sense. So if you recall, we have from negative infinity to minus 1/2 to this point here, this region we're testing. You can pick any test point you like within this region. You can pick minus 1. If I pick minus 1 within this region here, if I substitute that into our equation for each x, if I substitute minus 1, you would get minus 2. Is this true that minus 1 is a solution? We want the result of this be less than or equal to 0. So in other words, we want it to be negative. So yes, it is true, because if I pick minus 1 within this region, minus 1 works. So all the number from negative infinity to 1/2 would be part of my solution. You keep on doing this for each region. We want to test whether the solution exists from minus 1/2 to 1, which is this region right here. You pick a point. The easy points to pick would be 0. If I pick 0 instead of minus 1 we did previously, if I substitute for each x 0, this gone, you get 1 over 1 is equal to 1. Is this true? Is it true that 0 is a solution? We want this would be less than 0. So 1 is not less than 0, so it's false. Therefore, the solutions, it's not going to exist from minus 1/2 to 1. Usually the solution alters between these regions, since we already detected that all the way from negative infinity to 1/2 is a solution, and from minus 1/2 to 1 is not the solution. From 1 to positive infinity most likely would be the solution, but we can always check our answer by selecting a test point. Let's pick a point within this region. Well, 2 lies on that region. If I pick 2 and I substitute for each x2, you get minus 1 over 5. You don't really need to evaluate the value of this because you do care about the sign. Because from this region here, if I substitute 2, 2 would cause the top of the fraction becomes minus 2 plus 1. Minus 2 plus 1 would be a negative number. 2 would cause the bottom of the fraction becomes 4 plus 1, which is equal to positive number. So you see, we only really care about the sign of these. That would be negative. Negative some number, which is actually negative 1 over 5. And negative is good because we want the result would be less than 0. So that's true. also. So all the numbers from 1 to infinity would be the solution for this inequality. So here we can confirm the result using your graphing calculator. Plug the equation and you can see the solutions. So these are the steps for solving a rational inequality that we discussed earlier. Step number 1, you want to rewrite the inequality if necessary, so that 0 is on one side of the inequality. So you want to be greater than or equal to 0 or less than or equal to 0. So if it's a number like 1 or 2 or any expression on the other side of the inequality, you want to move everything to one side and let it be equal to greater or less than 0. That's the first step. And then step number 2, you want to determine the value that will cause either the numerator or denominator be equal to 0. So basically you pick the expression at the top and bottom of fraction, let it be equal to 0 and find those values. Those values would create intervals for you. So if you get only 2 zeros there, those 2 zeros would create how many intervals? So let's have 2. I find 2 points here. This point here and this point here on the number line. The 2 points would create one interval here, one interval here, and one interval. You get 3 intervals out of that, right? If I get 3 zeros, how many intervals you get? 1, 2, 3. Let's say I get 3 points. Then I get one region here, one region here, one region here, and one region here. So you get 1, 2, 3, 4 regions that you have to test. And that's all we do is just pick a point within these regions and see if it makes sense. That's what you do next. Let's take a look at this example. Solve x squared over x minus 2 less than or equal to 0. For those of you watching this later at home, now is a good time to pause the session and see if you can get the same answer. So step number 1, the given inequality has 0 on one side of the inequality and the sign, and then we have a single rational expression on the other side. We don't have to do much with that. Step number 2, the numerator we have x squared equal to 0 when x equal to 0. Denominator we have x minus 2 equal to 0 when x equal to 2. The x values then would be 0 and 2. Now we need to put that on the table or number line. Okay, I like number line, but we have both here. So if you look at your number line, the values that we're referring to would be 0 right there and 2. But we really have 2 zeros in here, right? Because we got x squared is equal to 0. We get x equal to 0, x equal to 0. So in reality, there are a couple of zeros, solution right there, right on top of each other, right, really. The reason I'm saying this is it appears that we make one region here, one region here, and one region here. But in reality, we had really 2 zeros in there. When we have x squared is equal to 0, x equal to 0, x equal to 0. So there is a region really between this here, but there's nothing there, right there. So remember when I said that the solution alter between the region? When you have a double roots here, double solutions, the solutions still alter between these regions, but you kind of have to count this as one region in there to come up with that. Okay, so we do have these points here. We have 1, 0 here, 1, 0 here. Now we need to select some test point. From negative infinity to 0, let's pick negative 1. Plug it in here. Plug it in your equation. Negative 1 would cause the top of the fraction to become some positive number, right? -1 would cause the bottom of the fraction becomes what? Some negative number, right? So I know I'm going to get some negative number. Actually, matter of fact, it's -1/3 if you plug the numbers there. So is it true? You want it to be less than 0, right? Less than 0 is negative. That's good. So all the numbers from -infinity to this point here, 0, must be the solution. Okay? Now, I can pick another point between 0 and 2, which is 1. If I do the same thing with 1, this would become -1. -1 is still negative, it's true. So the solution here again exists. So remember I said the solution alter between these regions? It does really. It's solution, no solution between this solution, and this shouldn't be any solution. If I pick 3 here, here I get 9. 9 is positive, not true. So the solution would be from -infinity to 0 and 0 and 2. So the solution set would be from -infinity to 2. Solving a rational inequality. Let's take a look at this problem here. For this one, it's not greater than 0. So our first job is to move everything to one side of the inequality. Let it be equal to greater than 0. How we do that? By subtracting 2 from both sides of the inequality. So here, this is my fraction here. So I need to combine these. This is x, this is x minus 2, and this is 1. What is the LCD here? I hear x minus 2. What else? The LCD among x, x minus 2, and 1 is what? It is x minus 2. Also, x is part of it, right? It's x times x minus 2. That's your LCD. So I need to make each of these terms to have x times x minus 2. Okay. So I need to multiply this first term by what's missing? X minus 2 over x minus 2. Multiply the second term by what? X over x. Multiply the third term by what? Both x times x minus 2, right? So I multiply the third term by x times x minus 2. Multiply the second term by x over x. First term by x minus 2 over x minus 2. Now I can combine these. I get x minus 2 minus x minus 2x times x minus 2. Distribute, combine like terms. I can actually factor a minus 2 out here. And this is factorable, would be x minus 1 times x minus 1 or x minus 1 squared. Now I'm ready to locate my zeros. What would be my first zero, anyone?
1.
1, because x minus 1 equal to 0, x equal to 1. Very good. What's my second zero? 2. X minus 2 equal to 0 means x equal to 2. What's my third one? 0. X equal to 0 means we have 0. So we have the 3 zeros. We have 0, 1, and 2. How many regions are we creating now? 1, 2, 3, 4 regions we have to test. Okay? We pick a point within those regions to see if it's a solution. I really like the number line, but you can use a chart. From -infinity to 0, from -infinity to 0 right there, you can pick a point. Well, my test point would be maybe -1, right? You plug -1 here, plug it in this, you get a negative number. Is this what you want? You want it to be greater than 0, so that's false. So there is no solution from negative infinity to 0. From 0 to 1, pick a point. Maybe 1/2. Plug 1/2. You give you a positive number. You put 1/2 in here. You get 2/3. So that's true because we want it to be greater than 0. So my solution from 0 to 1 is the first one we found. Any point within this region would be a solution because 1/2 checked out. Okay, we move on with the next region from 1 to 2. Pick a point. 3/2. Okay, we put 3/2. We work it out. It's true. So that is the solution. From 1 to 2 is also the solution. From 2 to infinity, plus infinity, would that work? Pick a number like 3. Looks like 3 is not going to work. Give you a negative number. False. So the solution must be from 0 all the way to 2. Solving a rational equation and associated inequalities. Let's take a look at f of x being 7 times x to the power minus 4 minus 8 times x to the power minus 2 plus 1. Part A, asking to solve the equation f of x equal to 0. We want to graph them and also use the graph to see when f of x will be positive or negative. We can rewrite this as 7 over x to the power of 4 because x to the power of minus 4 is equal to 1 over x to the power of plus 4. X to the power of minus 2 is equal to 1 over x to the power of plus 2. So therefore, this would be 7 over x to the power of 4 minus 8 over x to the power of 2 plus 1 equal to 0. So as you can see, I can make this equation here into a linear equation by multiplying each term by LCD. What's the LCD here? X power 4. If I multiply each term by x to the power of 4, each term here, multiply by x to the power of 4 over 1, you see x to the power of 4 cancel, you can only get 7 here. This would be x to the power of 4 over x to the power of 2 would be x to the power of 2, would be minus 8x to the power of 2. This would be x to the power of 4 times 1 would be x to the power of 4, and then this still 0. So you notice that I multiplied by LCD, I got rid of the fraction. I can write it in the standard form. You get x to the power of 4 minus x to the power of minus 8x to the power of 2 plus 7 equal to 0. I know how to factor this. And here I get difference in square. I can factor it again. So here would be my zeros. X squared minus 7 equal to 0. I get two solutions out of that. X would be equal to plus and minus radical 7. Then I would get x equal to plus and minus 1. Now if you look at your graph, you can see the graph below shows that the graph has 4 zeros, as we calculated. One is at 2.645, which is approximately radical 7, as we calculated. And the other one would be minus radical 7, the other one are plus and minus 1. Now, the solution of this, when is function less than 0, can be calculated by looking at the graph. At what point the graph would be below 0? Okay, from this point here, which is minus a radical 7, all the way to this point here, the graph would be below 0. So as this one. from this point on to this point here, the graph would be below 0. So you can see from minus radical 7 to minus 1, right there, the graph would be below 0. From radical 7, which is this point here, all the way from 1 to radical 7, this is 1 to radical 7, the graph would be also below 0. From 1 to radical 7, from minus radical 7 to negative 1, the graph would be below 0, right there. Where the graph would be above 0, when the graph would be greater than 0, would be from negative infinity to radical 7, from negative 1 to 0, from 0 to 1, right there, and also from radical 7 to infinity would be the solution. You just have to look at the graph, see where the graph would be below 0 or above 0. That's how you can determine when the f of x is greater or less than 0. This is an example modeling traffic intensity. It says vehicles arrive randomly at the parking ramp at an average rate of 2.6 vehicles per minute. The parking attendant can admit 3.2 cars per minute. However, since arrivals are random, lines from at various times. Part A, the traffic intensity X is defined as a ratio of the average arrival rate to the average admittance rate. Determine X for this parking ramp. So those two values are given to us, is 2.6 and 3.2. So X would be equal to 2.6 over 3.2, and this would be my value. For part B, it says the average number of vehicle waiting in line to enter the ramp is modeled by f of x is equal to, so this is given to us, f of x is equal to x squared over 2 times 1 minus x, where x is between 0 and 1. We're going to compute f of x for this parking lot. So from part A, we find x to be equal to 0.8125. So that's all I have to do, just substitute for each x, 0.8125, you square it at the top, 2 times 1 minus 0.8125. That would be about 1.76. So on average, there are about 2 vehicles waiting in line. Graph y is equal to f of x. What happens to the number of vehicles waiting as the traffic intensity approaches 1? When you look at the graph, you can see as this approaches 1, the number gets very, very large. It's going to increases. The number gets very, very large. And for last part, they're saying that solve f of x equal to 24. But so all we do is just set that equal to 24. And when you solve this, you just cross multiply this and solve for x. Here is not factorable, so I have to use the quadratic formula for that. So x would be about, or two values we get, 0.98 and minus 49. We're going to toss negative numbers that can not be true. We're going to reject the negative solution because the traffic intensity is negative. So the answer we're going to pick would be about 1. So about x equal to 1, the line is 24 cars on average. It's another modeling word problems here. A manufacturer wants to construct cylindrical aluminum can with the volume given to us as 2,000 cubic centimeter, which is 2 liters. What radius and height will minimize the amount of aluminum used? What would be this amount be? All right. So the unknown that we have here is a radius, x, and the height. To minimize the amount of aluminum, we minimize the surface area. So we need to know those two formulas. We need to know the formula for the volume and also the surface area. The volume of the cylinder is equal to pi r squared times h, or r is equal to x. And the volume is given to me as 2,000. So I can solve height in terms of other variable, which is x. Now the surface area formula is equal to 2 pi r h plus 2 pi r squared. Our radius is x. So in this case, if I substitute the values here, we know the value of height in terms of x. We already calculated that. Then you would get the surface area in terms of x would be 4,000 plus 2 pi r cubed over r, where r is x. And this is the value that's going to enter in your calculator. And you would find the minimum point here would be 6.827. So the minimum radius approximately is this value that our calculator would give us. And the height associated with that would be, plug it into that formula for height, would be 13.65 centimeter. So given a minimum amount of aluminum, that would be the amount right there for Y. 878.76 centimeters squared. Inverse variation as the nth power. Let x and y denote two quantities and n be a positive number. Then y is inversely proportional to the nth power of x, or y varies inversely as the nth power of x. If there exists a non-zero number k such that y is equal to k times x to the power of n. So let's take a look at this. When I say two variables are inversely proportional to each other, the variables that we're referring to are what? Are y and nth power of x. Nth power of x is this, right? That is nth power of x. So if two variables are inversely proportional, you would write y is equal to some factor k times 1 over the other variable. I could say y is inversely proportional to w. How would you write that? Y is equal to some factor k times 1 over w. I'm going to give you a few more examples to just make sure everybody gets comfortable with this wording. When I say y is inversely proportional to square root of x, how would you write it? Y is equal to some factor k, inversely proportional goes to the bottom of the fraction, would be the square root of x. Simple as that. You just read the question and set up the equation. So here it says, read this again. Y is inversely proportional to nth power of x. So nth power of x would be x to the power of n Inversely proportion means goes one. This is really is y is equal to some factor k times 1 over x power. If I say it's directly proportion, then you put everything to the top of the fraction. If I say y varies directly with x, how would you write it? Y is equal to some factor times x. This is directly, not inversely. When I say y varies inversely proportion to x, you would write y is equal to some factor k times 1 over x. If you get up to this point, the rest would be pretty simple. So once again, if I say some variable like y varies directly with x, so you would write as y is equal to some factor k times x. If I say y varies inversely with respect to other variable, you would write y is equal to some factor k times 1 over x. You could say jointly too. I can say y varies jointly with x and y. Well, x and w, it's a different variable. If I say y varies jointly with x and w, you say y is equal to some factor k times x and w. This is really jointly. I could make this combination of those two. I can say y varies directly with x, inversely with w. How would you write that? Y varies some factor k directly with x, so x goes to top of the fraction, inversely with w goes to bottom of the fraction. So you can see you don't have to memorize any of these formulas. You just have to read the question and just see what it is and write the formula. So let's move on to this example. The intensity of light, I, is inversely proportional to the second power of the distance d. Okay, let's see if we can come up with the formula here. So they're saying that I is inversely proportion. When it's something in inverse to direct proportion, there's some factor k involved. Inversely proportion to what? Whatever it is, I have to go to the bottom of the fraction now. Inversely proportion because it's inverse. Inversely proportion to second power of distance d, means d squared. So we have to set that up. I varies inversely with d squared. So we put I is equal to some factor k times 1 over d squared. That's why we get I is equal to k over d squared. Okay. Now, in order to solve for k, what do I have to know? Look at this equation here. In order for me to solve for k, can somebody tell me what do I need to know? I need to know a value of what? What are the variables we have? We have I and we have d. Okay, in order to solve for k, what do I have to know? I need to know the value of what? I need to know the value of d at some instant. So if you ever need to solve for k, somebody has to tell you, give you those information, tell you what the value of I and d is at some instant. And if you read the question carefully here on, it gives you that information. Models this phenomenon at the distance 3 meters. So they're giving you when d is equal to 3. When d is equal to 3, and then they're saying that 100-watt bulb produced an intensity of 0.88. We don't care about this 100 bulbs because the intensity is what we need, 0.88. Right? So they're giving you these values at some instant. They're telling you I is 0.88 when d is equal to 3. They have to give you that in order for you to solve for k. Once you solve for k, then you can solve for any other conditions, which they usually do that at the end. It says find the constant k And then once you know the K, they're asking you to find the intensity of the light at the distance 2 now, which is piece of cake. I can do that now. Let's look at the steps then. So we're going to substitute when D is equal to 3, I is equal to 0.88 to solve for K. Because remember, I was varied inversely with D squared. You just value for I, you substitute for each I 0.88, you substitute for each D 3, and you find K. Once I know K, now I know my equation turns to I is equal to 7.92 over D squared, right? So I can solve for D or I if you give me one of them now. And the next step is asking you to solve for I when D is equal to 2. So now I know all the information here. And you can solve for it. So the intensity at 2 meters is 1.98 watts per square meter. Let's take a look at this example here. Let M and N be real numbers. Then Z varies jointly. When it says jointly, it means there are more than one variables there. Z, right here, varies means we have some factor K, jointly as nth power of X, so it would be X to the power of N, and mth power of Y, it would be Y to the power of M. Okay, so that is my equation just by reading what they're giving me. Now I need to find K. In order to find K, somebody has to give me the initial or some values of Z, X, and Y at some point. Let's take a look at this example. The volume V of wood in a tree varies jointly with the 1.12 power of its height, H, and 1.98 power of its diameter, D. We're going to take a look at the figure here. The diameter is measured 4.5 feet above the ground. First, we want to write an equation that relates to V, H, and D. For those of you following this later at home, now is a good time to pause and see if you can come up with these values here and the equation, and then check your answer with us. So here's our formula. It says V varies jointly. So when it says varies jointly, this is V, varies jointly. So right away, we're going to put some factor K here. Jointly with what? It says jointly with 1.12 power of height. So it means H to the power of 1.12. And jointly with what? 1.98 power of D. So it would be D to the power of 1.98. Which is right here. V is equal to some factor K times H to the power of 1.12, D to the power of 1.98. It says jointly, and those are directly, therefore both H and D go to the top of the fraction. If I would say one of these are varies inversely, then I would put that at the bottom of the fraction, but it doesn't in this case. All right, in order to solve for K, somebody should gives me the value of V, H, and D at some point. Are those given to me? Yeah, they're giving us these values here. they're giving you the values. It says a tree with 1.3 inch diameter and 64 feet height has a volume of that. So they're giving you these three values for the diameter, height, and volume at some instance, right? They're giving me that. I just plug it in here, solve for K. Once I find K, now I got my formula with the constant K. This formula here is there with the constant K. So now I can solve this for any other conditions. If somebody give me the value of H and D, I can solve for V. If somebody give me the value of V or H, I can solve for D, and so on. So in this example, they're giving you the scenario. They want you to estimate the value of the wooden tree width. They're giving you D is 11 and H is 47. So if I know D and I know H, I can solve for V. And that's exactly what we're going to do. I can solve for V when these two values are given to me. So for that condition, if D is equal to 11 and H is equal to 47, the volume must be about 11.4 cubic feet. Let's take a look at this example here. The strength S of a rectangular beam varies directly with its width W and the square of its thickness T, and inversely with its length L. A beam that is, okay, I'm going to stop right here. I want to see if everybody can come up with the formula just by reading the first two lines. So for those of you watching this later at home, I suggest you pause the session right now and see if you can come up with the formula just by reading these first two lines. Okay, so far, I should be able to come up with my formula here. It says S varies, so I'm going to put some factor K here, directly with W, so W goes to the top of the fraction, and square of T, so that goes to the top of the fraction, and inversely with L, so L should go to the bottom of the fraction. Does that make sense? That should be my formula. In order to solve for K, I have to read the rest of this to solve for K. Somebody should give me the value of S, W, T, and L at some point, and looks like we're having that here. So the beam that has, it says a beam that is 4-inch wide, so I have my width is 4, and 10-inch thickness is 10, and 120-inch long, L, it support a load of 1,250 pounds. So now I can get this information to find K. So let's take a look at all these first, and then we're going to find the rest of these. So for right now, we find S is equal to some factor K times W, T squared over L, and the values of S, W, L are given to me, so I can solve for K. Just plug the numbers here and then solve for K. So you should get K is equal to 375 if you do this correctly. Once I know that, then I can use the equation number 1 to solve for S when W is equal to 3, T is equal to 12, L is equal to 100. Now I know my K is equal to 375. The only unknown is S. And that would be about 1620. Okay, so we have a question here. How do we solve for K from here, from this point on, right? So we have 1250 is equal to 10K over 3. You're okay with this point, right? How do you solve for K? You multiply both sides by reciprocal of 10 over 3, right? So it would be 3 over 10. 3 over 10, you're solving for K. So K would be equal to 3 times 1250 divided by 10. Does that make sense? You get it? Okay. So that's why we have 3 times 1250 divided by 10.
You go back to the other side?
This one here?
Yeah.
Go back to this. So once again, we have 1250 is equal to 10K over 3, right? You divide both sides by reciprocal of this coefficient. And that's your K. You're just solving for K.
Okay.
Right? So K must be equal to 3 over 10 times 1250. So you got that.
Yeah,
That's what you 3 over 10 times 1250. So now find K. Once I find K, I can go ahead and solve for any conditions, right? I know K, so they're giving you the value of W, T, and L, so I can solve for S. Rate of work. If one tank can be completed in X units of time, then the rate of work is 1 over X. 1 over X task per time unit. It takes machine B 1 hour less to complete a task when working alone than it takes machine A working alone. If they start together, they can complete the task in 72 minutes. Now the units are different. We need to take care of that. How long does it take each machine to complete the task when worked alone? All right, so let's see what we got. We're gonna let X represent the number of hours it takes the machine A to complete the task alone. Then working alone, machine B takes X minus 1 hours. We must have time units. So in this case, we have 72 minutes. We need to convert it to hours. So with 72 over 60, that's the first thing we're gonna do. Make both units the same as hours. So 1 over X is the rate for machine A alone. 1 over X minus 1 is the rate for machine B to work alone. 1 over 6 over 5, which is 5 over 6, is the rate for two machines work together. So remember, we figured this together, we convert this to the minutes. So it would be 1 over 6 over 5, which is equal to 5 over 6. So we have all the information we need to set our equation. 1 over X plus 1 over X minus 1 is equal to 5 over 6. Now, how do you solve for X? We have an equation involving fractions. We need to multiply each one by LCD. What's my LCD? LCD is X times X minus 1 times 6. If I multiply each term by 6X times X minus 1, then we guarantee to eliminate all the fractions. There we have our fraction. You distribute, get into the linear equation, factor, and then solve for X. X equal to 2 over 5 or X equal to 3. Now we have to see if these answers make sense or not. The value 2 over 5 must be rejected because it would cause the time of machine B to be negative. We're gonna take, it takes machine A 3 hours to complete the task alone. And it takes machine B 3 minus 1, which is 2 hours to complete the task alone.